Well, good afternoon, everybody, and welcome to this session, Advanced Excel Updates for Accountants. My name's David Livertilly. I'm the Head of Standards and Technical here at SIPFA, but in my past career, I've been a full-time Excel expert in an accounting firm, and I was previously running the Excel community for ICAW as well. So I have been around the space of Excel training and standards and applications for some time. I wrote a weekly Excel blog for something like 10 years with updates and tips. So I'm going to be sharing with you this afternoon a few of my favorite things. The particular focus for today's session, I've chosen things which I think are perhaps more about more modern Excel usage, so things added over the last few years. But I'm trying not to make this just a who's who of new features and what's been added, but focusing on the things which I think are the most useful, the most accessible, the most time-saving from those newer features. We do have a few things in there which I think are older features as well to look at. So there's quite a broad range that I've picked out. This is, of course, my selection of what I find useful and what I think is most worth sharing. But we are not going to fill the full hour that we have today just with what I've got in my materials. I've intentionally left a pretty chunky amount of time for your questions as well. So if you are interested, you can send in your questions. So using the Zoom platform, you have access to the Q&A feature, and you can use that to send in your questions, and we'll answer those toward the end of the session. Other than this opening slide where we're holding on in PowerPoint, in a moment I'm going to be moving over into Excel, and you'll be able to follow everything in the file as I'm doing it. We did send around a copy of this file just last week, end of last week, so you might have got access to it already. You don't need it for the webinar, but if you'd like to try playing along with things or seeing things live as you go, you can do that. I will probably make updates and changes to that file throughout the session today, and particularly if we get into Q&A, I might add some bits to address Q&A. So don't worry though, we'll recirculate the workbook after the webinar with the final version with anything that I add to it over the live period, and we will also circulate a recording of this webinar as well. So if there's anything that goes by too quickly or that you want to reach out and check again, you'll be able to catch up with that recording later. So that is where we're at in term for the session and the overview. I'm now going to get myself ready and share my Excel screen with you. So if you just give me a moment to do that. Okay. So we are now sharing, and you should now be able to see my screen. So I'm going to get stuck in. I'm going to try to remember to zoom each of these screens in as much as possible, just so that they are easy for you to view on the Zoom webinar as well. So I've talked at the front here about a few of the things which I think some of the perhaps older features which might be familiar to you, some things you might have used in the past, which actually newer features essentially have replaced and make it more straightforward. So we're going to go over a few of those things that have been replaced. And I'm going to talk about some of the newer functionality. But the first thing I want to talk about is actually probably the newer feature in Excel that I use the most frequently, which is the paste values, that kind of classic option. This is something that lots of people want access to and was previously quite a complicated thing to do via the keyboard. So these are formulas right now. You can see here all multiply numbers by 5. If I want to just keep these values and ditch the formulas, I can use Control-Shift-V now, and that will put in the formulas, remove the formulas and just leave the values. So if you want to have access to a nice quick keyboard shortcut to start, I think that's always worth mentioning. We're going to start with a really important shift in Excel that happened a few years ago, but is still being the kind of implications and consequences of which are still being felt, which is a huge change to the calculation engine, and that's to bring in what are called dynamic array formulas. So you might have come across some of these accidentally because there's a lot of it in Excel now, but I want to kind of talk about it all holistically. What is a dynamic array formula? Well, this is a new type of function that they put into Excel that lets one formula take several values and fill up several cells. They are a really useful way to work with and understand data, and they make the operation of creating data that works on like a whole range simpler and allow you to make more efficient and more flexible formulas. And there's all particular functions that come with dynamic arrays that are also useful for doing some pretty common tasks. So I'm going to be using this example here of where I've got a few different people booking onto an imaginary training course. So with names here, with some job titles and some prices. And I'm going to use this data for all of the examples that will follow. It'll eventually go off the screen, but the only thing to notice, we've got names in C, job titles in D, and prices in column E. So that's what we'll see throughout. So an example of a good first example of a function, and actually I can keep this on screen, a dynamic array function is the unique function. So this is equals unique, and you can see here I pointed that function at the column D9 to D18. That one formula returns the unique values from that whole column. So for example, you can see that we have multiple people with the same, with the financial analyst job title in the source data, but it only appears once in the output. And there is only one formula here. If I delete the formula from cell C22, the whole thing goes. So that one function spills out of this cell and into all these others. If you've not worked with dynamic arrays before, if you highlight one of the cells further down, you can still see the formula, but it's kind of grayed out in the formula bar. That's how you know that you're dealing with a spilled cell. And you also see that we've got this pin line highlight around the block. So if I select any of the cells inside the array, Excel points out to me which cells are currently filled. If I type some nonsense in the way of the spill, we then will see this hash spill error appear. That's because this formula is trying to spill into more cells, but there's data there already, so it won't replace what's already there, but it cannot work while there's that data in the way, so we will need to delete that if we want our dynamic array to work. So there's an example of a dynamic array. And the reason that this is called a dynamic array is that it will also change if I change the content. So if I, for example, take this person and I also make them a financial analyst, so you see there that now my formula has shrunk one cell because I got rid of one of the unique job titles, and there's fewer of them now. So that's a bit about how those work. There's lots of other things you can do with it though. So here's another function called sort. So the sort function, again, looking at our job titles here, will take that same data and return it sorted. By default, that sorts alphabetically. And what we've got over here is a combination of functions. So here we're using a unique to get just the unique job titles, and then we have got a sort that is then putting those into alphabetical order. And actually this sort function you'll see has got a input called sort order, for example. So I could say if I wanted it to be in descending, so reverse alphabetical order instead, I could write a formula that does that for me very, very simply. We also have a few other options. So a more recent addition to the suite is a function called group by. So I'm actually going to rewrite this formula from scratch over here just so that we can see what this looks like. So group by is a function that allows us to take data and group it in some way. So we start, if we're looking at our inputs here, with the row fields. So this is going to tell us what's the thing you want to group by. So I'm going to scroll up a little bit to my table. So let's say I want to summarize this data by my job titles. I'm actually going to include the header here, more on that in a moment. Then we are going to have a comma. Our second input here is to look at the values. What are the values we want to do to group with? I'm going to select my prices. The third input, you can see it's giving me a selection of options here, is what formula do I want to use to do that grouping? So we're just going to do the simplest one, which is a sum. So we'll enter that there. So we want to use a sum to do that. And then we then have this, that's all of the necessary inputs to this function, but we have this options, a few other optional ones, and one of the useful ones is called the field headers. So that's asking, does the data that we just selected include headers or not? So I'm going to use yes and show, option 3. So yes, there are data headers here, and yes, I want to see them in the output. So having written that simple function, I now get, if I just make my columns a little bit wider, a grouping. So we have one row for each unique job title. We have a total of the prices for each of those job titles, and we have a grand total at the bottom as well. So that whole table is generated using just a single function and can be made very easy. Over here, it's the exact same thing. I've just I've formatted the prices to use a pound sign format, but it's the same data. Let's look at some other examples. You can also use this functionality to filter. So here is a filter function. So here the array that we're looking at, the inputs, is column C, which if you remember is the names. And then I've got an include argument here where I'm looking at the job title column D, and I've asked if that column is equal to this value in cell C59. So here at the moment I've got financial analyst here, and it is filtering the list to just show me the 3 people who are financial analysts. If I change this to accounting manager, and we've just got the one of those accounting managers, Michael Harris, so you can see my formula is now only occupying 1 cell. You can also do useful things in formulas by using a bit of careful formula language. If you wanted to do a function that looked at how this range, normally you might have to select the whole range. So you'd say, C59 to C61, but that would always be those 3 cells. What if I want to do something like, for example, counting how many people have met my filter condition here, but I want that to, of course, change as this dynamic array gets bigger and smaller. And the way that you do that is a hash. So D59 just refers to whatever's in D59, but D59 with a hash on the end is D59 and anything that spills out of D59. So the count A function here, which just tells me how many non-blanks I have, tells me that I have 3 people with this job title. But if I change it to an investment analyst, just got the one of those, and you can see now my D59 hash only refers to D59 itself. So that reference grows and shrinks as the spilled data grows and shrinks. So this also means we can do things like easy numerical operations. So for example, here I've written equals this whole price column times by 1.2. So I've told it to multiply that whole range by 1.2, and what that does is that returns the entire column of values times by 1.2. So each one of those values has had that same thing applied to it. So it's just an easy way to kind of create a range there. And there's lots more. We'll actually see some other dynamic arrays a little bit later in the presentation as well. So they're really helpful functionality because they let you do things that were difficult or impossible to do before. They also just have this really neat functionality where they can easily expand data. And actually the hashing thing does more than just, does quite a lot of stuff to it. You can also do things like equals this set of numbers multiply this by this set of numbers. So, and you'll see that the dynamic array will fill in 2 dimensions. So you can get something that will automatically grow a formula like this. And there's also actually a very helpful function for making things like this. So let's say I wanted to start this over with, let me put a 4 at the top here. There's a function called sequence. So sequence, if you have equals sequence, and I'm pointing at the number 4, will make the numbers 1, 2, 3, and 4. You can also, instead of rows, make it with columns. So I'll do it here with a column input. And then I could do something like, is this sequence function multiplied by this sequence function will make a little times table. And the nice thing here is if I make this into a 7, it instantly grows the 2 sequences, which grows the formula that multiplies them together. So you can make functions that grow and shrink according to the parameters that you state. This is obviously a pretty simple example here with my times table. It's not particularly something you do, but what you might do is have, for example, something that uniquely draws unique headings from one area, unique headings from another, and then does a formula to combine them in an interesting way in the middle. So that whole thing just for just 3 formulas. We are going to move on to talk about XLOOKUP in a moment. I think this might be a good moment, though, with a lot of new things, just to quickly check in on the questions. So my colleague Florence, I think, is on the line as well, and is going to be helping me out with some of the questions. So Florence, are there any questions on this section before I move on to the next one?
Not yet, but people might be typing, so I will let you know once any question comes in.
Perfect. Thank you, Florence. I think what we'll do is I'll move on to talk about XLOOKUP because that's very closely related. It's another dynamic array. And if we get some questions in, we can tackle them together.
Oh, we do have one just come
perfect.
in
Let's
now.
take it.
And it's to ask if we can copy and paste an array table as values.
Hmm. Yes, you can. Obviously, it will know it'll lose that sort of growing shrinking effect, so you can use the same thing. So that's using my Control Shift V shortcut, and then now it is just a list of numbers. Now there's no dynamicness going on anymore. So if I did something to the original data, this will not grow and shrink anymore. It's just the numbers. So yes, that is absolutely an option.
Um, and then another question's come in about the sequence function and
Mhm.
whether you could just put a value in the cell and populate each month up to the value. So say December,
Uh-huh.
and then be able to populate all of that up to the point
Yes,
that
yes,
you've
you could
selected.
absolutely do that. So there's a couple ways you can do it with, so sequence just generates numbers, although you do have some options in the function here, start and step, that let you do things like saying, if you don't want, so start would change where the function begins, and step changes how big each step is. So by default, it starts at 1 and counts in ones, but you could use this to say, well, I want to start at 100 and go down by 3. But you can also use this to fill in dates. So for example, as we're recording, it is the 19th of May 2025. If I wanted to generate a list of dates, I could say, I could take this value here and I could say, well, what I want to do is say sequence. Let's say I want 100 items in it. We're going to, ooh, typo slightly, we're going to start at the 19th of May 2025, and each step will be 1, so that's actually a default, I don't have to put that. Now these will not come out formatted like dates because Excel and dates is a bit weird, but if we format this as dates, we can see there we go, there's my list of 19th, 20th, 21st, and so on. So you can generate a list of dates in that way as well. I'll do one quick extra example with this. There's a function called workday. Workday lets you calculate the working day n days after a starting point. So if you just wanted a list of working days, you could do something like this. So working day, let's say again that my start date is the 19th of May 2025, and my number of days forward I want to skip is a sequence of, let's say, 10, well, let's do 30. But we're going to start at 0 this time. So we're going to go 0 up to 30, and that will be the 19th, 20th, 21st, 22nd, 23rd of May. Then we skip the weekend, 26, 27, 28, 29, 30. All this does is skip Saturdays and Sundays. You can include holidays as well. The workday function has an input where you can specify other holiday dates, but that's another option you could do with this type of function.
There's a few more that have come in. One relating to being able to group by several fields.
Yep.
So more than one field, for instance.
Yes, I'm going to come back to that one because we're going to talk about pivoting a little bit later, and there is a pivot by
Mhm.
function that is probably the best one for doing that kind of thing. So I'll pick that up in a little bit later in the presentation, and if that doesn't quite cover the person's question, we can pick it up after that.
Okay. There's one that is not quite array related, so it might be something that maybe you might
Okay,
address later
we'll
on.
park that. Let's press
Let's
on.
do that.
I'll do the next couple of sections, and then we'll check in on the questions after the next couple of sections.
Yep.
So let's talk about XLOOKUP. So there are lots of functions to do lookups in Excel. So the ones I've listed here are lookup, VLOOKUP, HLOOKUP, and index match. So these all do a flavor of the same kind of thing. And in almost every situation, XLOOKUP is better than any of them. So this is a relatively new function. It was designed to replace these older functions. It's much more flexible. It's much easier to write. But I should start by talking about what is a lookup. So a lookup is any kind of function where you're trying to find a value based on a label, based on some kind of description. So you might have a person's name, you might have some sort of other information, and you're going to use that to try and identify a value related to that name. So let's have a look at our example. Here is our pricing table for an imaginary event that Cipher is going to run. We've got different prices we're offering to different types of members, and we've got our master table here. Now down here we have a version of our same data earlier. This is ChatGPT generated data, by the way, with some made up names and council authorities. I've then randomly assigned them each a type of subscriber. And now what we want to do is use each row's subscriber type we want to use to look up the appropriate price for that person. So let's have a look at the formula that we've written here. This is the XLOOKUP function. This is the way that it's done in XLOOKUP. So first of all, we have a lookup value. So this is what do we want to look for. And we're immediately starting using a dynamic array here, because you'll notice that my lookup value here is not one value, is not just Emma Richardson's subscriber type, but the entire column, because XLOOKUP lets me work as a array, so I can use one formula to look up every single row of data. Then we have a lookup array. So that is where are we going to look for that? We're looking for it over in our subscriber type set column here. And then finally, we have our return array, which is what we return afterward. So we just point at those two columns, we point at the column we want to look at, and that is an XLOOKUP, and that will return the value for everybody. Now, interestingly, you'll see we've got one NA error here, one not applicable. So that is currently failing to find a value for this particular item. And we'll talk about that, why that is in a second. But one of the advantages that XLOOKUP has is it has several other alternate inputs. And one of the extra inputs, so one of the extra inputs, as well as a lookup value, an array, and a return, is what to do if you don't find it. What should happen? So, for example, I can put "not found" in quotation marks because I'm making text here. And then now that is what my formula does if it can't find the person. So if you're used to using something like an if error function to do this kind of thing, it's just baked into XLOOKUP. You can just automatically have it specify. I mean, I could also put, I don't know, let's say 0. Let's say if I can't find them, then they get it for free. That's 0. So you have that option. The problem here, by the way, is that this person, whoever's done this data entry, has put a space on the end. So you can see it's network subscriber space. If I fix that, it'll fix the formula. So that's another option that XLOOKUP has. And there are actually a couple of other options as well, but I'm going to come on to those in a moment. So there's an example here. So I talked about this Workday example earlier. Here is an example of how you could use a lookup to do a match for a exchange rate. So I have my Workday function here, which has got me a list of the working days from 1st of April to the end of April. So that's given me a list of dates. I then have the USD to GBP exchange rates on each of those dates, which incidentally is being done using the stock history function that automatically pulls exchange rates from Microsoft. So you can see, I'm not going to go into detail on this function, but if you want to have a look at the file, you can see how that works. And then I have written my table over here of pulling out the appropriate exchange rate for transactions on each of these particular dates. So this is working just the same as before, where I have a table that I'm looking up, a table of dates and a table of values. Now, the problem here is that one of my transactions took place on the 20th of April, which, if you don't recall, was a weekend. So my exchange rate data doesn't include an exchange rate for that day. So I'm currently getting an error message. But there is actually another one of these extra inputs in the XLOOKUP function that we can do called match mode, where there are a few different options. And in particular, what I'm going to do is take this one, exact match, or the next smaller item, which you can see is -1. So now if it can't find the 20th of April, it will take the next smallest item prior to that. So if I do amend like that, I now get a rate of 1.3294. So that's the rate from the 18th of April. So the most recent exchange rate in my table is used instead. So that's another option that you have with XLOOKUP. If you've used VLOOKUP or index match before, you might be familiar with this. One huge advantage that XLOOKUP has is that VLOOKUP does this in exact matching by default. You have to explicitly tell it to using a false or a 0 to do only exact matching. XLOOKUP does exact matching as a default, and you can choose to do it this way, which I think is hugely superior, because exact matching is what you want 99 times out of 100. But if you do want to do it this way, you've got this option. I'm going to go to our final kind of topic, a small topic on this dynamic array excursion, and then we'll take another pause for questions. And that's talking about text manipulation. There's a whole bunch of new text manipulation functions also added into Excel. And a lot of them are also work for just fine as dynamic arrays. So just going to have a look at a couple of those. So one of them is the text before function. So this is a very easy way of finding the text before some kind of a delimiting character. So you can see here I've applied it by looking at this list of Booker names. That's my input text. I then have to specify a delimiter. In my function here, I've got that as quote space quote. And what that is pulling out all of the first names, everything before the space. And there's also a function called text after, which is, unsurprisingly, pulls all of the text from a given range that is after a delimiter. So here, everything after the space. So there is my list of surnames. And there's a few other things I can do as well, actually. So if I want to take a list and then glue them all together into one, there is a function called array to text. So array to text has the option, it just takes the text, a list of text that's in an array or in a column, and just glues it all together into one with a comma separation. So that's the array to text function. There is a slightly different option here if you want to get it in this sort of machine format, but the 0 option, what it calls concise, is the easier one. And actually you can do this in reverse. So let's say you've all been given a list of names in this format and you want to split it all out, then there is a function called equals text split that you can look at some text and say each row is separated by a comma and then a space, and it will take that single cell with names joined by commas and split it into one cell per name. So there are simple functions for both taking lots of text and putting it into one cell, or taking one cell and splitting it back into lots of text. And this can essentially replace the text to columns feature, but this has the advantage that text to columns is something that you do once and then it is done. This is a formula. And the nice thing about formulas is, let's say that this is not a formula, but this is handwritten, and I write Florence, my colleague on the end here, because it is an array formula, immediately the result is appended to my array as well. So you've got this live updating feature that we're used to with most formulas, which is definitely preferable. Right, I'm going to take a quick drink, and while we're doing that, I'll go to Florence to see if we have any further questions on what we've spoken about so far.
Well, not quite on the ones we've just shared. We still have that pending question that was going to be about dynamic range, putting a dynamic range in a formula. And I
Okay,
wonder if this is a good time to take that question, but we can always
sure.
park it towards the end if that's okay.
Give me a little more detail on it. It sounds like we should be able to cover it now.
Yeah, so the question is, can they can they put a starting point and an ending point in a formula and
So,
use that to
yeah,
create a dynamic a range that is dynamic based on those values that they've imputed in the formula? So say A1 to A3.
yeah,
But yeah.
but just be able to change the start point and end point easily.
Mm,
Yes. So the short version of that is yes, and there's a few different ways that you might do it. So obviously, normally you wouldn't just be typing cell references into something like that, but you might be doing something like a lookup on one particular value. So let's say you wanted average exchange rate, and you wanted to have that between, let's say, the 15th of April and the 28th of April. So I want to be able to change the period to which this average is applying. So one thing I could do is I could say an average of a X lookup of this on this range and returning this one, colon, an X lookup of this one. This is live stuff, so I'm not 100% sure if this will work the way I want it to the first time, but let's give it a go. 1.33083. Let me just double check that. 28th of April. Average is 1.33083. Yep, perfect. So what I've done there, so XLOOKUP actually, this is another thing that XLOOKUP does. So XLOOKUP doesn't directly return the value that it looks up. It actually returns the cell address where the value is. So I can use it either side of a colon, just the same as if I were writing, as you say, normally I might write average A1 to A3 like this. instead of writing cell references directly, I could use an XLOOKUP to identify them. And now I've got an average over that range that I specify. But if I change the 28th of April to, let's say, the 21st of April instead, then my average now covers the new range that I've specified in a dynamic way as well. So that would be the kind of situation where I might expect to see something like that. So you can do that with an XLOOKUP function. You could use it as one or both ends of a range that will change in size accordingly.
Okay. Thanks for that, David. There's a new question, and this is around the formatting of numbers. So where you're using a lookup, for instance, I don't know if this applies in all the different lookups, but if you were looking up between a number
Mhm.
and a different set of values that are numbers but are formatted as text, you
Ah,
tend to
yes,
end up with an error. But is
you
there
do,
a easy
yeah.
solution
Uh,
to sort that out?
Yeah, so this is the thing that happens. This particularly is common when you've imported data from some other program where something might be formatted as as text, and Excel is then not doesn't understand that these are numbers. So if I try to take a number and look it up in this table, let's just return, I don't know, this doesn't really matter. It's not going to work. Even though I, as a human being, can see this number one and can see this number one, and I believe these are the same, Excel thinks that these are text values, and the text value one is different from the number one in the way that Excel thinks about things. And there are formulas that can convert things. So the quickest option, for example, is if you do something mathematical to a text value that represents a number, Excel will then realize that it's a number and convert it. Although you actually have the option to do that directly in the formula. So if I were to multiply this array by 1 in the middle of my formula, it should, there we go, now work. It will convert on the fly into a it converts these into numbers which it can then use properly. So you can use something like multiply by 1 to coerce that data into force Excel to view it as numbers, even if it doesn't think that they are numbers. If you actually want to convert the underlying data, by the way, another cute trick here is if you take a number one in a cell that is formatted like a number, copy, then you can select the data and you can go do a paste special. So let me go paste special from the menu here. There is a paste special multiply option. So that will, instead of pasting the number one, it will multiply that whole range by one, and that also will convert it into numbers as well. So that's another cute, good trick for doing conversion.
Nice to have a few options. I think we're out of questions for now, so do keep them coming as we go through the next session.
Okay, great. Let's talk a little bit quickly about data types. So this is a interesting feature that I personally wish that Microsoft did a little bit more than this with this, because it's quite helpful for the stuff that it covers, but it's relatively limited in scope. So what this is data types. So this is something where you can tell Excel that some data you have in a table is of a particular type, and there are, from the data tab, these types that it automatically recognizes: organizations, stocks, currencies, and geography. And when you do that, it will then add a bunch of functionality related to it. So I'm going to very quickly show you what that looks like with a couple of options. The stocks type and currencies type is the first one to look at. So we're going to talk about currencies. So I've got here listed some different exchange rates. So what I'm going to do is I'm going to select this and select the currency pair data type. I'm actually, it doesn't recognize it for the heading. So let's put this into a table first of all. I'm going to press Control T to make that a table. And then I'll come to my data here and I'll say that, yes, this is a currency type. It is then able to recognize each of these as a currency type. And you can see that there's a logo by them now. And I can now add columns to my table that are related. So because it knows that these are currencies, I can look down here and see, oh, I've got ticker symbols, names. I have got the 52-week high and low exchange rates, etc. The one I'm probably going to want to use at the moment would be a most recent rate. So that will be, let's take an open rate for each of those currencies. And there we go. Now I have got an open rate for each of those currencies or each of these currency pairs, I should say. So this very quickly gives us, this is how many yen gets per pound. Oh, actually, this is the other way around. So this is JPY to JPP, so it's a very small number, Japanese yen to pounds. You could have these, if I put these the other way around, you'll see it in the more familiar format. So 193-ish if you have them that way around. So that is a nice little automatic recognition things. This also works for stock prices. So if you want to look up stock information in your Excel, you can do that too. So that's another option that you have. I'm just going to undo this so I don't have a random mix of currencies in here. There we go. And you can also do this for countries. So let me again make this into a table. So I'm doing this with Control T, which makes Excel. I'll recognize this as a table, which is a helpful thing for lots of sorts of data analysis. And I'm going to label these as geography. So give it a second to do that. Okay, so we have a little map icon next to each of these because it's recognized this. This doesn't just work for countries. You can do this for counties and subregions and addresses as well, and it will do its best to identify each of them. And the advantage I have here, so again, there are things you can, there are facts about that country that I could add from this little icon here. So I could say, oh, I want to get, what's the name of their national anthem, or what's their official language, what's their largest city, what's their GDP, all that kind of information. But for countries, I think the main advantage is if you've got some numbers here, you once you've labeled these as geography, you can go to Insert Maps and insert a filled map chart. And there we go. There is a map of all of the countries that I've got in my list, coloured according to the size of their sale amount. And that takes about 10, 20 seconds to do. You can do more things to mess around with this and exactly how it's displayed. And, like with any chart, you can do some work to get it, with add labels to it and change how it works. But if you just want to do a quick and dirty sort of sales chart or something like this, you can use this this data type and the standard map chart type to do something, and you can see it will just figure it out pretty quickly. So I think that's another option that's pretty handy as well. I'm going to press on to talk about our pivot table example now, and then we'll take another pause for questions after that. I'm going to guess that probably most people that are in this have at some point encountered a pivot table, but I think it's worth spending just a couple of minutes talking about what they are and how they work. And also I want to talk about the pivot by function. So I have got here, this is actually a very old data set that Microsoft used to supply with their database software access back in the day. It's called the Northwind dataset, although I've slightly changed it for this particular example. We've got just over 2,000 orders of goods to an imaginary chain of grocery stores in the US. I've got various columns with information about each of those orders, and we are looking to summarize this data in a nice, convenient way. And I think easiest way to do that is to go insert pivot table, and that will automatically detect my data is here from A1 to H2156. And I can put this data on a new worksheet. And a pivot table essentially summarizes and crushes down that data into a smaller format. So you can see that my original data is still here. My pivot has been added. I'm going to call it, give a name to this tab, pivot table. And my column headings are now appearing on the right as the options for how I want my data summarized. So let's say, for example, that I want to know the quantity of items ordered by each customer. So I can do that by just dragging customer name to, let's say, the rows column. There's all of my customer IDs, and the quantity column I'll drag to the values box. There's a quantity of items ordered by each of these customer IDs. So that is a very simple way of doing things. If I wanted to split that out into, let's say, what's a good column for adding over the top? So I've got various different products names here and various different product dates. Let's say I did it by date. I could take the order date column and add that to the columns list. And there we go. This has now given me a summary of how many items were ordered by each customer in each of the years of the data that covers. And it's actually automatically grouped it together, but I could expand 2024 into quarters, into months, and even into individual days if I so chose. So a pivot table is a really quick way of creating this kind of summary, and there's lots of other stuff that you can do with it. I just wanted to point out that there is also now a new function called pivot by that lets you make one that's formula driven. So let's say, in fact, let's make exactly this kind of table. Let's do equals pivot by. Let's say that we are going to once again care about our quantity column. That is my row field. Oh, no, I have to be careful. These are in a different order as a group by. So the row fields are what is going to be going down the rows of the spreadsheet. So let's say that that's going to be our customer names. Our column fields, let's say, are going to be our dates. Our values are going to be our quantity columns. And the function we're going to use to summarize them is the sum function. So you can see here that my first input is my row fields, my column fields, my function, and my values. And that information will then generate that whole pivot table in a single formula. Now you can see again, it's the dates are not formatted correctly, so they're just looking like numbers right now. It hasn't done the aggregation because I haven't done anything with it, but you do have options to do that kind of thing. So for example, if I wanted to do this by year, I could take my column fields and just wrap them in a year function, and that will condense it into 23, 24, 25, because it's we're taking that operation and just extracting the year of that value before we're putting it out. We have actually got loads more options as well. So you can filter, you can sort the orders of the different columns. So if you're doing something a more complicated group by, if you've got multiple categories to group by, for example, this is the way that I would look to another way of doing it. The advantage of the pivot by function is that unlike a pivot table, if you let's say that I'm just going to make this quantity 1,000,000. The pivot table over here will not update until I manually refreshing it using data refresh all. Whereas this pivot by function, because it is, this is willmemk, there it is, because it's a formula, it's instantly updated to include my 1,000,000 order there. So that's one nice advantage of using the pivot by approach instead. I'm going to take another pause for questions there, and then after time depending, we might talk a little bit about sensitivity analysis after that.
Absolutely. So there's a short question asking for the source of the currency rate. I think you mentioned during the session that it came from Microsoft, but I don't know if
Yeah, it
then
is my Microsoft provider. I can't recall off the top of my head which ultimate source they actually use for this stuff. It comes out of their like one of their various business departments. I don't actually know off the top of my head what that source is. So I'm
okay.
afraid I'd have to look that up.
Okay, we can come back to you in the pack
Yeah.
later on when we share it. So someone wants to know what the advantage of using tables is because they don't
Oh
use
yeah.
it yet and they're wondering what they're missing.
So I really like tables. Let me talk about them real quick. So if you make some data into a table, actually I'm going to do this with my pivot data function. So let me make myself a little bit of working room. I'll make a few blank columns. So you can make data into a table either from home format as table or with control T. It gives you a couple of advantages. Firstly, you don't have to have this stripy appearance, but you can. I find that makes it much easier to read. And actually, one nice thing about this is that it keeps the stripiness even when you filter it. So here, for example, you can see this first 10249 value is in white. If I filter this out to hide the 10248s, now it's in blue. So whatever filtering you do, it always shows it with alternating blue and white rows. So that is helpful for reading across. So that's a minor help. The really nice stuff is it makes it easier to refer to data. So let's say if I put a formula in, let's say I'm going to do order value. I'm going to create a new column, and you can see just by typing the header, the table grows to include it. You can type a formula in this cell and it will, so if I did, D2 times 100, it automatically copies the formula down the whole column. But you can also, if you do this more directly, let's say that's the unit price multiplied by the quantity multiplied by 1 minus the discount. So that would be the value of this particular order after applying this discount. You can see that the formula is written using the column names instead of the cell names, cell references, and that makes them easier to read. They've got these ats in them because they are only applying to this particular row. But if I was doing something outside of the table, I could actually, let's say I wanted to add up my new order value column here. I can do that directly. The way that I would do that is if I come into my table, you can see I've got this table design menu up at the top here. I can give a name to this table. So let's call it Northwind Sales. And now I can use that name and I can use the column names in a formula. So let's say I want to go equals sum Northwind Sales and then a square bracket and then the name of the column I care about. So let's say the order value column. And I can make a formula like this equals sum of Northwind Sales order value that will give me a total for that column. And that is a much easier formula to read and understand than just a I2 to I2000 and something. It tells you which table you're looking at and which column. But also, if I then later on come in and I add a new column with a new item in it, like this, my formula is automatically copied into my new column. And if I just put in some random numbers here, that 900 is now automatically included in my total up here as well. So it means that I can make a formula that automatically grows. So it's a similar kind of functionality to what dynamic arrays do, but is a bit more useful, I think, for like storing of data. You can assign these names, and it just makes it a little easier to refer to and work with. If you're interested in doing more stuff on tables and data handling, by the way, we are doing a webinar a little bit later in the year on Power Query, which is a data manipulation tool inside Excel, and that can be used to do all sorts of what are called extract, transform, load. So it gets really into applying transformations to data and reorganizing and rearranging it in various ways. That we're going to get into a lot more detail in that webinar. So if you're interested, do come along to that one. We'll be talking about how you can connect tables together and create lookups and references between them automatically, that kind of thing, as well as accumulating lots of separate tables and gluing them all together automatically into one big one, that kind of thing. So just a shameless plug from me on that if you're interested in that topic.
And just in time to plug that, because now we have another question around, can you create data field pairings? And this sounds like something that you might be looking to do in Power Query.
Yeah, well, so there are some options to do things like if you want to create a connection between two tables. So where for example, this is just this data, for example, comes from a larger data set, the Northwind data set. So there is another table which, for example, maps each of these customer names to an sort of codes to an English language customer name, their address, and who the principal contact is at that company. So you could do something like creating a connection between these two tables so that you could easily read across between this table and that table without having to do any kind of formulas at all. And that's something that Power Query and the related tool Power Pivot are really good at. And we're going to be talking about both of those in the other webinar. They're a little bit too involved to get into today. So we've got a whole webinar dedicated to that topic.
And just on the question of pivot tables, there's a question about, well, where you have grand total, for instance, where you can pick to see a total of a pivot table, could you do a variance instead? Because we're always comparing budget to actuals, aren't we?
Yes, we are. So you can do things like to an extent with that. So if I come over to this box on the right here where I've got my sum of quantity, I have the option value field settings. So this is where I can change how these values are being dealt with. So for example, I didn't tell it to add up the quantity numbers, it just does that automatically. But if I wanted to average them or find the maximum or any other kind of calculation instead, this is where I would change that. And there are also some options to show value as. So currently it's not doing anything special, but I could say, for example, change it to something like percentage of the grand total or percentage of some other value. So I could do something like what percentage of all of the orders is it? So if I did the percentage of grand total, okay, so Alpha-Key is responsible for 0.34% of my orders by volume, for example. So you can do things like that to to make some changes. If you want to do things like comparing to forecasts and budgets, I don't want to put too much of the content over onto that second webinar where we're going to talk Power Query, but that is actually something that you can create things called measures, which will do things like comparing forecasts to actuals and that sort of thing. So that we'll probably get into that in that one as well. But you can, even with a basic pivot table, do quite a few of those options using this show values as, and some of the calculation options is you can see ranks and indexes, running totals, percentages of various different values. So you've got quite a lot of options in there as well.
Thanks. David, have we reached the end of what you're planning to show us?
I've got a little bit on sensitivity. Let me do that for
Okay.
just a couple of minutes, because it's
Yes.
just a quick one on this, but this was a specifically requested topic when we put up the webinar. So I want to talk about this just very quickly. So there is a net present value calculation that I've created for this example. I'm not going to talk about this at the actual example at all. All that I've got is that this has various inputs here. It has a reasonably involved calculation with a few different steps to it, including here, and then that it ultimately computes a net present value. Not going to talk about NPV today. What I am going to talk about is some of the tools that Excel has in it to help you investigate these kinds of complicated calculations in a little bit more detail. And this is a relatively simple calculation compared to the sorts of things that people make in financial models and so on, but the presence is overall the same. The first thing I want to talk about is GoalSeek. So GoalSeek is a tool that you can use to vary an input to get to a target output. So let's say, for example, I'm interested in what discount rate would make my net present value fall to 0. I could just do that by manual experimenting. So 4% is not enough, 5% is not enough, 7% is a bit much, 6, somewhere between 5 and 6. I'm kind of manually changing this and keeping an eye on this net present value as I change it step by step. Or you can just get Excel to do that process for you. And you do it through data, what if analysis, GoalSeek. It's a bit hidden. And then you just tell it what you want. I want this cell to equal 0, and I want you to accomplish it by changing this cell. Okay, there you go, done. 5.590633,285, etc. percent gets you a value extremely close to 0. That's my internal rate of return for this particular project. You also have an option that's called a data table, which can be used to tabulate the results of changing one input to a whole bunch of different values. So again, if this was just a single formula that just led from the inputs directly to the outputs, this would be simple to do. But because there's lots of multiple intermediate stages here, this is a bit more difficult. But again, there's a tool in Excel that does this for you. This is very good for doing sensitivity analysis. It's called a data table. So here are various different initial sales numbers. So my initial sales number in my actual sheet is 9,000. I want to see how my NPV is affected by all these values. All you have to do, I've got a formula here that is just linking to the cell with the net present value in it. I'm going to select where I'd like my data to be, same menu, what if analysis, data table, and my inputs are in a column, as you can see. Oh, whoops, didn't mean to actually click there. My inputs are in a column, so the column input cell is the box I need to fill. So this is me saying, well, these inputs in a column, they should be plugged into D5, the initial sales figure. So these numbers plugged into there, and there is an output telling me the value for each of those numbers. You can see that there, for example, 2,708, that is the current value. And you can actually do this for two different inputs at the same time if you use this layout. So here I've got different initial sales values and different discount values, discount rates. And again, I've got a formula at the top that is linked. So all I have to do here is select. I have to be careful. My house is being slightly funny with me. Select the data, what if analysis, data table, a row input cell. So the inputs that are in a row are these percentages, which I'd like to try out as the discount rates. My column input values, these are these numbers that I'd like to try out instead of the sales value. Hit OK. And there we go. We have got, what have I done there? That's slightly wrong. So those do look there we go. I think what's gone wrong is that I've moved around a bit before it's ready. So I'm going to leave it to recalculate because that's going to take a second for it to recalculate all those values. So that's a little bit about the sensitivity analysis tools. The one thing I should note about data tables is that they are incredibly memory and processor heavy. They are really take a lot of your computer's attention to produce, which is why you've got to be a little bit careful with them because they can cause problems. For example, I accidentally interrupted it when it was doing that there and it didn't quite work. So I need to 2.5. Oh, I think these might have actually been my discount rates. Column input cell as my initial settings values in D5. There we go. Maybe there we go. I must have misclicked. So you can calculate this, fill in this data using a data table. If you've got a big financial model with data tables in it, though, it will slow your computer down quite significantly. And you can tell that because on the formula sheet, you can see you've got options here, and you have the option only calculate everything automatically, calculate everything manually, and then this option, this middle one called partial, and by what it means when it says partial is everything that isn't a data table. They are the single thing that it switches off because they really are that bad. Right, any further questions, Florence?
There is one more just on pivot tables, and someone's wondering if they can stitch two pivot tables together rather than going back to the two separate base data for the pivot tables.
Yeah, so there are a couple ways of doing that. The simplest way is to connect the data together into one, which you can either do using a formula approach. There's formulas called VStack and HStack that can stack data in like together on top of one another. This is another thing that Power Query is really good at doing, is connecting data into one pile. Or alternatively, you can look at some tools to connect the data together. It's one of those things that depends a little bit. Like if all I've got is maybe more data in exactly this format, but just let's say it's the 2019 to 2020 data, I'm better off stacking them together into one table. If I've got some slightly different data that uses some of the same terms and fields, I would probably be better off connecting those two using Power Query or Power Pivot to read between them and doing a little bit of data connection instead. So it depends a little bit what you're looking to do exactly, but there are definitely ways of making your life a bit easier there.
That's all for the questions, and just in time because we have reached the end of the hour nearly. We have a few materials to share with participants, and it's just really to let you know about our Excel sessions. If you return the screen share to my
Yes,
one,
can do.
then I can go through that.
Okay, just while you're getting that up, Florence, just to note, because I can see there's a couple questions that, if you didn't get a copy of the file pre-webinar, don't worry, we will send you a copy with all of the stuff that we covered over the course of the session, once this is over, and you'll get the recording there as well. Are you having an issue? Is the screen share acting up for you there, Florence?
It is, Elizabeth.
Okay, let's maybe not worry about it then, because I'm conscious that we're up at the end of time. We will make sure that we'll share all of that with you, along with the recording of the webinar as well. And we were going to make sure that there's time. I tried to go a little faster today to make sure we could cover more material. I know that not you have been able to get absolutely everything over the hour, but you'll have the recording available as well if you want to go back over things and go a little bit slower and check them out. So don't worry about that. And we'll also make sure that we provide information on the answering some of the other questions as well. And that also will include information on the Power Query, Power Pivot webinar, where we're going to be getting a bit more into detail about connecting data together, manipulating it, and so forth. It looks like we've got your slides up now, Florence.
Okay, so it's really just to say If you're looking for Excel on demand, if you're a member of SIPFA, you can access some more materials on demand for Excel. And then to also let you know when the sessions for Power BI will be, the Power Query rather, will be coming up. So we've talked about quite a bit, some of the things that you could do better in Power Query. So that's 10th of July. And I've put some links in there, which we can share with you afterwards for you to book onto that session. So it'll be similar to the way you've booked onto this session. It'll be free for members, and non-members will just pay a token. And that's it really.
Great. Thank you very much, everybody. Thank you for coming along. We'll leave you with this slide on Public Finance Live. I will be there, and many of our others will be as well. So hope to see many of you there. Thanks again for joining, and hope you found the session helpful. Thanks, everybody.
Thank you. Bye.